All right, this was the piecewise function you should have gotten for number 6. So the x squared in the red would have been your parabola. It was less than 1, so it started at 1, and then which would have had an open dot arrow pointing left. The y equals 3 is a horizontal line. That's the blue one. It's less or greater than or equal to the 1. That's why it's solid on the left, but then less than the 3, which y is open on the right. And then the last one is y equals negative x plus 6. So that's the yellow, and it should have the solid dot. Yep.
The orange one, why does it got one lower? I got like the same thing, but I got one higher.
So the y-intercept is 6, right? 1, 2, 3, 4, 5, 6. And then the slope is negative 1. So down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. It should have been there.
Oh.
Maybe just count it off.
Oh, no, I got it. Okay, I got it right, because I just got it one higher.
Got you.
Yeah.
Yep.
Can I use the charger?
Like you need to borrow my charger or you need to charge?
Can I like borrow it?
Borrow. All right, this is the calculator one. This is going to happen on your test. One question with a lot of parts based on what you're graphing. So that's the graph. I drew all over it, but that's the original graph, okay? And I would say almost the first thing you would want to do if you're welcome, saw this is figure out my max and mins because that helps with your range. It helps with your increasing, decreasing. So maybe answer that question first. The max and mins, there was 2 relative maxes, negative 1.2 and 7.3, and 0.9 and 9.1. I didn't tell you to round to the nearest tenth on this, but it will on your test. And then from there, well, our domain is negative infinity to positive infinity, but the range, that maximum y is 9.1. So from negative infinity to 9.1 with a bracket on the 9.1. And then, the minimum, is negative 0.2 and 4.6. Then our increasing, decreasing behavior, it started increasing from negative infinity up to the x there, which was negative 0.2, negative 1.2. Then it changed direction, came back down from negative 1.2 to negative 0.2. Then it went back up again from negative 0.2 to positive 0.9. And then it came back down again from 0.9 to positive infinity. The 0, like the scientific notation part is not bad, but it should still round to the nearest tenth. It might not be exact, but it should still round to the nearest tenth. So the 0 there, and notice I listed them. I don't want them in coordinate point form. You want to list a 0. If it was intercepts, you put them in coordinate point form, okay? But check on that because it should be closer. And then f of 3.5, this is where we go to value, and we type in 3.5, and you should get negative 446.9. It would take you forever to plug the 3.5 into this equation. You do have a calculator, so it makes it a little bit easier, but that is such a waste of time when you can just go to that value menu, so make sure you know how to do that.
Does decreasing not get a union? It only works like some.
There's only one to, is there one to, oh no, it's there. I just put the picture above it. Sorry, it should be there. That's a U, yeah. I put the picture on top of it. Questions? So not only is this a good representation of your test question, but it has so many parts, it's going to be worth a lot of points. So keep in mind that you want to be really careful with the calculator part. You are starting with this part. So test is a week from today. You'll start calculator, you'll switch to non-calculator, so you can go back to calculator if you need to. But then you're done with the non-calculator part. I'll keep talking about it all through next week so we know what's happening. But that's the order. All right. 1-4. So the good news is this should mostly be review, okay? This is stretching, shrinking, reflecting, shifting of parent functions. So we start with the parent functions you have to know, okay? The very basic ones are horizontal lines, like a constant function, and then linear functions, or specifically this one is an identity function, which is just y equals x or f of x equals x. It doesn't happen very often, but we could even ask you to shift these. Like I could take the f of x, that's the line, and ask you to shift it up, down, right, left, okay? It's not going to happen often. Like I don't even think it happens in the homework. It's not going to happen on your test, but in a standardized test, they could ask you to do that. For each of these graphs, you want to keep in mind that you should be able to determine domain, range, increasing, decreasing behavior, and even or odd. So if you look at the constant function, is it even, odd, or neither? Even. Why is it even? Good. I could reflect it over the y. If I go to the identity function, what's that? Even, odd, or neither? I know it because I only gave you 3 words to choose from and you didn't say any of them. Even, odd, or neither? Odd. Why is it odd? Good. Everything that happens in the top right corner is folded over into the third quadrant, okay? All those values, so this is 1, 1, become the opposite sign, -1, -1. This is 2, 2, -2, -2, okay? So that one's odd. Domain is all real numbers, range is all real numbers, and it is increasing the entire way. On the constant graph, domain is all real numbers. The range would just be whatever the value of C is. So it looks like it's almost like a 1.75. That would be your range. And it's constant the whole way. So tonight's homework for 1.4 is a PDF. Okay, I want you to hand draw these. And every question asks you to identify domain, range, increasing and decreasing behavior. So keep that in mind as you're doing the work. Without those, you're going to lose points. Okay, then we get to the most common of the parent functions. Absolute value. God bless you. Which is a V. These would actually have arrows on the ends. Quadratic, which is the parabola, also would have arrows at the ends. The square root function, which is kind of hard to see, but it would be a parabola turned on its side like that. 1/2 that parabola. God bless you. And then the cubic function, which in this looks, it's actually going above the axis. That wouldn't happen. It would be here, and then it would be here. So it's like a parabola with the left side flipped down. Joey.
We have to remember that.
Yep. So it's going to ask you to transform a certain equation, and based on the parent function, you'd have to know exactly what it originally started like. There's these 4 and 2 more. These are the most common. So let's say I asked you to give me domain and range for these. Let's start with the absolute value. What would domain be? All real numbers, negative infinity to positive infinity. What would range be? Good, 0 to infinity, and the 0 gets the bracket, right? Because it's a solid dot. Is there a part of the graph that is increasing? Where?
0 to positive infinity.
Good. Parentheses or bracket?
Bracket on 0.
Nope.
Parentheses.
Good. Pretty close. But yeah. Remember, increasing can't be, like a point can't be increasing. So increasing and decreasing will always get parentheses. So having said that, what is decreasing? What range? Good. Good. Is this even or odd?
It's
Or neither?
even.
Even. And it is exactly the same for the quadratic function. Domain, range, increasing, decreasing, and even. All the same for those two. If I can fold it on the y-axis, like left to right, fold it like a hot dog, then it's y-axis, which means even. If the top right is reflected in the bottom left, like across from one quadrant to second, third quadrant, or second to fourth, then it's odd. And if it's neither of those things, it's neither. So like square root function is neither. What's the domain on the square root? 0 to infinity with a bracket on the 0. What's the range on the square root? 0 to infinity, bracket on the 0. What part is increasing? 0 to positive infinity. Is there a decreasing? Is there a constant? No. And we just said this would be a neither function. It is not even nor odd. Last one, and we won't do this every time, but last one, cubic function, domain. Negative infinity, positive infinity, range. negative infinity to positive infinity, increasing.
Negative infinity is like 1, and then
So it's actually, I know it's really hard to see this, but it's going up the whole time. So it's increasing the entire way.
so the middle part wouldn't be constant.
No, it doesn't flatten out.
Okay.
It's hard to see right around it, but if it was drawn accurately, it never would flatten out. Because like 0.1, let's say, cubed is going to be 0.1, so it's going to be above. Negative 0.1 cubed is going to be negative 0.1, and it's going to be below. Okay, how about even, odd, neither? Odd. This time it's odd. Everything in that top quadrant got reflected across to the third quadrant. Good? So again, these are parent functions. This is like recall. You have to know, if I ask you to graph something that has a bunch of shifts and it starts as a square root, you have to know what the square root function looks like. Have to know absolute value, quadratic, and cubic function. These two are less common, but you could see them, and that is the cube root function and the reciprocal function. Cube root, if you took the square root going in the first quadrant and then you reflected it into third, that is a cube root function. It's a parabola turned on its side with the right side flipped back. And then the reciprocal function, if you remember your rational equations, they have a vertical or horizontal asymptote at the x-axis, a vertical asymptote on the y-axis. And so if you look at that domain and range, notice it starts and stops. Domain goes from negative infinity to 0, but can't include the 0 because there's an asymptote there. And then it goes 0 to positive infinity. Range, negative infinity to 0, and 0 to positive infinity. And then even though it's in two parts, it is decreasing the entire time. So decreasing from negative infinity to 0, and then again, 0 to positive infinity. Both of these are odd functions. This one's also odd. Both of these are odd functions because they're symmetric to the origin. Questions so far? So that's your baseline. Now we're going to start to move them all around. The first shift is a vertical shift. If you are adding or subtracting something after the function, it's shifting it up or down. So those are the first four. If it was like the fraction, it would be 1 over x plus a number, or 1 over x minus a number if it's a reciprocal function. If you add outside the square root, outside the absolute value, outside the parentheses, it goes up, and if you subtract, it goes down. It's a parabola. If it asks for it, and it will, it's going to say, what's the parent function? It's going to give you a line. You're going to write x squared. So it's called, that's its name. Its name is a parabola. That's the shape would be the u. But the actual parent function is f of x equals x squared. So what translation is happening in A? Up 1. So I'm going to go up 1. I'm going to plot my point. And then with the parabola, you would go up 1 and out 1. So I go up 1 and out 1 in either direction and draw your parabola. How about B? What's happening there? Down 2. So I go down 2, up 1 and out 1, and I draw my parabola. Questions on that one? All right, next up is the horizontal shift. This happens inside the function, so in between the absolute value, underneath the square root, inside the parentheses, or if it was the reciprocal function, in the denominator. And this one goes left to right, but the opposite that you would think. If it's a plus, it goes left. If it's a minus, it goes right. All right, example 2. What's the parent function? X squared. What's happening in A? To the right 2. So I go to the right 2, up 1, out 1, draw your parabola. What's happening in B? The plus 2 inside is what? Left 2, good. The minus 3, down 3. And it doesn't matter which one you do first, left and down or down and left. It doesn't matter. I tend to go left and then down, but it doesn't matter. And then again, up 1, out 1. Still good? How many of you remember these pretty well from last year? Good, okay. All right, then we get the reflection. So there's 2 types, over the x-axis and over the y-axis. Over the x happens if the negative is on the front of your trig function. Of your, what did I just say, trig function? I'm jumping to like January. Of your, in this case, quadratic, absolute value, any of these functions, okay? If the negative's out front, it flips it over the x-axis. That takes my parabola and points it down. It takes my absolute value and points it down. It takes my cubic function and flips it so that it is left side up, right side down. And it takes my square root and it points it down. So this, by visual, is upside down. But when it asks you to describe the transformation, it needs to be reflected across the x-axis.
So for the square root, it doesn't change like the side the axis is on?
No, that's the bottom. Oh, it would change what side the axis is on.
It changes the x, but not the y.
Correct. If the negative is in the function, so specifically the most noticeable is the square root. It happens to all of them, and we'll talk about it in a second. But if it's inside the function, it flips it across the y-axis. So my my square root that normally points to the right would point to the left. Yeah. Yes. So it would go left and down. Yep, it would be like that. All right, so think about what happens if there's a negative inside absolute value or inside your square function. Didn't put the negative. Or inside your cubic function, okay? If I took my absolute value, which looks like this, and I flip it over the y-axis, what happens? Stays the same, okay? How about my parabola? Stays the same. How about my cubic function? It flips, but it looks just like if the negative was on the outside. Those do the same thing, okay? Now, here's the catch to it. If there's a horizontal translation and a negative, now it's something different. If I had negative x plus 2 squared, pretend the negative's not there first. What would you do with the plus 2? Left 2. I'd put it here. I'd draw my parabola. Now the negative's here, so I have to flip it over the y-axis. Where does it go? It goes back to the other quadrant, right? It goes from the left quadrant to the right quadrant, or vice versa. So there's 2 ways to look at that. One, do what we just did, graph it without the negative, then flip it over. Or what I think is easier is if there's a negative here, it changes the direction that you go horizontally. So if I had absolute value of x minus 3, which direction is my absolute value going? Nope, to the left. Because it would go right, but then it would flip over the y. Does that make sense? So that's, you could do both together like that if you want to, or you could flip it. It doesn't matter. And when in doubt, what could you do? Plot a point. Plug in 0. See what happens. What'd you say?
Ask for help.
Ask for help. Okay, if you're on your test, because I can't help you with that stuff on your test, you could always plot a point, okay? So if you're like, crap, I don't remember this rule, where does it go? Plug in a value. Didn't mean to do that. Questions? All right, so now, what's our parent function? Square root x. What's happening to a? It's upside down because the negative in the front over the x-axis or upside down. And the plus 1 means left 1. So I go left 1 and I draw my square root pointing down. Yes.
It was outside the square root.
Then it points left.
The one.
Oh, then it's a vertical shift.
Okay.
Yep. Yeah.
How do you know how like far down or up the line?
These are really approximations. Technically, you would go up 1 and over 1, but then after that, it would depend on like your values. So you're really doing an approximation. The only exact point I expect on a square root is that -1, 0. And then the rest of it is an approximation. When you start to stretch and shrink, which we're going to get to in a second, we'll talk about how you differentiate that. But if it wanted something more specific, you could plug in a point. You could plug in 0, and you'd get -1. You could plug in 1, and you could go like that. Yeah. All right, so then for B, what's the negative inside doing? Flipping over the y, or point it left, if points left, in like normal words, okay? What's the plus 3 doing?
Down 3.
Almost.
Left 3.
Up 3. I appreciate that you're participating. All right, so I go up 3, and then I point it left. Still good? Yeah. What's the domain on A? -1 to positive infinity. What's the range?
Negative infinity to 0.
Good. Negative infinity to 0. Is it increasing, decreasing, or constant? Decreasing only from -1 to positive infinity. It's going down, right? Yeah. So you're falling as you move from left to right. Ooh, that's not what I meant to do. No, but you're doing the x values. So the x is still getting bigger. Yeah. Everybody good so far? Yes? Okay. Non-grid transformations. There are 2 types. There's vertical and horizontal. We're just going to focus on the vertical for now, okay? The vertical transformation is called a vertical stretch or vertical shrink. In the AP language, they say vertical stretch and vertical compression. It means the same thing, okay? But they changed the language. So a vertical stretch is like taking my graph and literally stretching it top and bottom. So if it's pointing up, it's pulling it up. So it's making it more narrow. If it was pointing down, I'd be pulling down from the bottom. It would be making it more narrow. If it's a parabola, it's going to be more narrow. An absolute value, more narrow. A square root is going to grow taller, okay? Those things happen when the number that is being multiplied by the function is greater than 1. Now I'm ignoring the negative because the negative is a reflection. So this is just the value on C. If that value is in between 0 and 1, so we're talking fractions, decimals, okay? Then it is a vertical shrink. It is as if the ceiling is caving in on our function. So it would make a parabola wider. It would make a V wider. It would make an absolute value flatter, okay? That's what it's going to look like. Okay, so graph the function, and these are approximations, but we'll talk about exactly how that happens in a minute. Now, what's my parent function? Absolute value, which looks like a V. Thank you. Okay, the 3 on the front is doing what? Okay, so we say narrow, or we could say vertical stretch. I'm not moving left or right at all, so my 0 is at 0. Now this is actually like my slope. Instead of going out 1 and up 1, like a normal absolute value would do, it's actually going up 3 and out 1. And that's what becomes more narrow. If you are drawing a parent function and then a stretch function, as long as it's more narrow, I don't need it to be exact, okay? As long as it is more narrow than normal. If you're plotting those points, then you use that number on the front as slope for absolute value and also for your like quadratic. Instead of going up 1 and out 1, we would go up 3 and out 1. How about the 1/2? What's it called? It's called a vertical shrink or compression. And it makes it wide. So I go 0 and I go, instead of up 1 out 1, I go up 1 out 2. Questions? All right. Example 5. Identify the parent function. Describe the sequence of transformations from F to G. Sketch the graph of G by hand. And I'm going to let you ignore D to use the function in terms of the parent function. Ignore that, okay? Do this. And the next one, same thing, okay? So write it out. Describe it. You can use symbols to talk about the transformations. And then you're going to graph it by hand. Let's see how well we can do. What's your parent function? X squared. So again, make sure you use the equation, not the word. It is a parabola. That's its name. The actual parent function is x squared. No. F of x equals x squared. Yep. I mean, you sure can, but I'm going to dock you points, so don't do it. Okay. All right, Kevin, describe the sequence.
Okay, so the sequence would be up 3.
Good.
A vertical shrink.
Good.
2.
Wait, vertical stretch.
A vertical, a stretch?
Yeah.
Oh, yeah, that's what it says. Okay.
Yeah.
Can I just write narrow? And then it would be to the right 4.
Good. So right 4, up 3, vertical stretch, which makes it narrower. Good job. And this, like, you're going to get a line for this, like, describe the sequence. I'm fine with arrows, like, up for an arrow up instead of actual words, that's fine. Just make sure you separate them all out, okay? That plus 3 could be at the front or at the end. That's why it's still, if it's separated out. And if it was a negative like this, now would be a reflection over the x-axis or pointing it down, okay? So just because it's not at the end doesn't mean it's not a vertical shift. Now, the other thing that you're going to see in tonight's homework, so remember, again, it's a PDF. You're drawing this stuff out. You're doing the domain range and the increasing, decreasing. The other thing you're going to see is a graph that's already graphed, and you have to come up with the equation, okay? There aren't going to be non-grid transformations, so you don't have to worry about narrow or wide, but like, let's say it looks like this. How do I know that equation? First of all, it's absolute value. It's down, so I put a negative out front. It's to the right.
3, so it'd be a minus 3.
Yep, and up 2. Okay, you're going to have to come up with that based on the pictures. Same for your test. So don't worry about the non-grid transformations, the narrow and wide. But all the like shifts right, down, up, left, and reflection, you need to be able to identify.
Would it also be okay if you did, like, this question didn't put the 2 in the front?
Yeah, like 2 minus this.
Yeah.
Yep, totally fine. All right, you've got 6 minutes. No, 7. No, I'm going to publish it now.